I'm Grant, and welcome to another episode of Super Adventures in Physics. Today's lesson is heat. Let's talk about temperature, heat, thermal energy, and phase changes. Alright, let's talk about temperature. Temperature can be described as quantitatively by using a thermometer, or qualitatively by using descriptive words. For instance, when picking up a glass of ice water, you feel a sensation that is also known as cold. Likewise, by picking up a cup of coffee, you feel the same sensation that can be described as warm. This also can be inaccurate though, due to a very important variable, which is the temperature of your skin. On that hot summer afternoon, that cold glass of water will feel even colder, because your body temperature has actually risen. I needed that. After shoveling another foot of snow here in Minnesota, your hands are actually pretty cold when you come back inside, so your body temperature is probably lower. So what do? You go next to a fire. And when you put your hands to a fire, it'll take actually longer because your body temperature is colder, and you're going to need more energy to heat up your hands. Let's talk about thermal equilibrium. Here I have placed ice in room temperature water. Notice that none of the ice has melted, so this glass is not in thermal equilibrium yet. I also have here a second glass of water with only 3 ice cubes left. Several of the ice cubes have melted and the water has gotten considerably colder. This glass is closer to thermal equilibrium than the first glass. Here I also have a third glass of water, and this has been sitting here for over 30 minutes. And this glass has finally reached thermal equilibrium because there's also no ice left. Another example would be when I place this soda on top of this room temperature counter. These two are in thermal contact with each other. Eventually they will reach thermal equilibrium. Now let's talk about phase changes. Phase change can be from a solid to a liquid to a gas, a solid to a gas, or vice versa. An example would be boiling water. Boiling water is going from a liquid to a gas, or water to steam, like this. Alright, let's wrap this all together. So first, by plugging in the popcorn maker, it heats up the pan to a designated temperature. Next, by adding the oil, it becomes in thermal contact with the pan. Next, by adding the kernels, they begin to heat up because of the transformation of energy by the pan. Okay, so now the kernels are absorbing energy until they are at a high temperature, which then they rupture like now. At this point, superheated water inside the kernels are actually suddenly turning to steam and rushing outwards, like up top. The kernels then burst open to form fluffy, edible puffs of starch, known as popcorn. Well, I'm glad my dryer and this t-shirt came in thermal contact. Alright, well I have some notes to review. So first we found out that temperature can be qualitative or quantitative. Then we found out that objects can be referred to as hot or cold, which is actually very inaccurate due to the skin temperature that is needed. We also found out that two objects at different temperatures, when they are in contact with each other, instantly try to reach thermal equilibrium. And the final temperature that they will reach is in between the two. We also learned the definition of heat, which is the transfer of energy between objects at different temperatures. And the unit used to measure heat is joules. Also, we learned about phase changes. Remember back to the boiling water example, where the water changed into steam, which is obviously a phase change, or a liquid to a gas. This required actually a lot of amount of energy to do. And also, there was thermal conduction when the pot is heated up from the burner. Then the final example, which is making the popcorn, is actually a review of all 4 things that we talked about. First, by plugging in the popcorn machine, it rose the temperature of the pan. Next, when we used the oil, it actually came in thermal contact with the pan. And after adding the kernels, the energy was transferred from the pan to the popcorn, which then heated up the kernels. Once the kernels began to pop, energy was released, and actually the water from the kernels was made into steam. The steam was then released, causing the popcorn to be puffy.
What?
And tune in next week for another exciting episode of Super Adventures in Physics.